Turning market analysis into business insights. In this lesson, we explore how real customer and market data is used to answer business questions. We focus on transforming market analysis into actionable insights. Understanding customer satisfaction, campaign response, and purchase behavior helps improve products, services, or marketing. You will learn how to extract key findings from datasets and deliver clear recommendations. Practice converting data patterns into business actions. Running the cell now. We import pandas for general data handling. We import numpy for numerical operations. We import opaml to access public datasets. We import warnings to suppress less important warnings. We filter warnings to keep outputs clear and focused. Running the cell now. Understanding customer and market datasets. We will use authentic customer satisfaction surveys, marketing campaign responses, and online retail data. Each dataset captures real-world details, from demographics to open-ended customer feedback. Survey data often comes with ranges, ratings, or missing responses. Beginners often forget to check for missing values, encoding mistakes, or biased group comparisons. Running the cell now. This example loads an authentic customer satisfaction survey from OpenML. We fetch the dataset using OpenML. The data is returned as a pandas data frame for analysis. We print the shape to understand how many records and fields are present. We inspect the first 3 customer responses. Running the cell now. This output shows the loaded customer satisfaction dataset with 7,043 rows and 20 columns, reflecting a rich mix of demographic, service, and billing information. Notice how the first few rows include key columns like gender, tenure, and churn status, highlighting typical survey variables that may contain categorical and numerical data. This confirms successful data import and sets the stage for checking data quality, such as missing values and proper encoding, which are crucial first steps in working with real customer data. Try to find the column that indicates if a customer left, churn. In this step, we bring in a real online retail transaction dataset. We download the Excel file directly from UCI, loaded into pandas. We convert invoice dates to date times so we can later analyze time trends. We print the data shape to understand the volume. We view the first 3 transactions to see the information captured. Running the cell now. This output shows our loaded online retail dataset contains over 500,000 transactions and 8 key columns, including dates, product details, quantities, prices, and customer IDs. Notice that invoice date is correctly converted to date time, enabling time-based analysis, while missing customer IDs hint we may need to handle incomplete data later. This confirms the dataset's scope and readiness for exploring real-world retail patterns as we learn to manage and interpret customer and market data. Can you spot what field might indicate repeat purchases? This example generates a synthetic Net Promoter Score (NPS) survey for practice. We set the seed so results are reproducible. We create each customer with ID, age, region, and an NPS score from 0 to 10. Each row is a separate customer response. We check the data's size. Finally, we view the first 3 NPS survey responses. Running the cell now. This output shows a dataset of 500 customer survey responses with 4 columns: customer ID, age, region, and NPS score. Notice the range of ages and regions, as well as NPS scores from 0 to 10, which reflects typical survey data with numeric and categorical variables. This step helps beginners confirm the data loaded correctly and understand the basic structure before exploring patterns or missing values. What score range makes a customer a promoter in NPS? Now we analyze how customer churn rates differ by senior citizen status. We group customers by whether they are a senior and look at normalized churn counts. The output shows what % of seniors and non-seniors left the company. Running the cell now. This output summarizes customer churn rates grouped by senior citizen status, showing the proportion of customers who stayed, no, versus those who left, yes. Notice that senior citizen equals 1, have a higher churn rate, about 42%, compared to non-seniors, about 24%, highlighting how demographic segments can differ significantly in customer retention. This helps reinforce the lesson's point about carefully examining group comparisons and potential biases in survey data. What does higher churn among seniors suggest for retention strategies? We want to know what share of customers make more than one purchase. We count transactions per customer. Next, we check what fraction of customers have more than one transaction. We print the repeat purchase rate as a business metric. Running the cell now. This output shows the repeat purchase rate calculated from the retail dataset, indicating that 98.19% of customers made more than one transaction. Notice the high rate suggests strong customer loyalty or frequent buying behavior, which is key for understanding market engagement. This code highlights the importance of grouping data by customer and aggregating transaction counts to reveal critical business metrics from raw sales records. How might you use this rate to plan a loyalty program? Now we analyze how response rates to marketing vary by customer education. We load the campaign data from OpenML. We rename columns for clarity. We group by education and calculate the share of positive and negative responses. The output shows which education segments are most or least responsive. Running the cell now. This output shows the proportion of marketing campaign responses, coded as 1 and 2, broken down by education level. Notice how the positive response rate, 1, tends to decrease as education level increases from primary to tertiary, which may indicate differing engagement across groups. This summary helps highlight potential patterns or biases in campaign effectiveness that are crucial for targeted marketing and should be carefully interpreted alongside data quality checks. Which education group should receive more targeted marketing? Understanding where customers are most likely to recommend us is valuable. We group NPS scores by region and calculate the average for each. We print how customer sentiment varies by location. Running the cell now. This output shows the average Net Promoter Score, NPS, for each region, highlighting customer satisfaction differences across geographic segments. Notice the variation in mean scores, which signals how regional factors might influence customer loyalty. This step is crucial for identifying target areas in marketing strategies and ensuring accurate group comparisons without missing or misencoded data. Which region might benefit from service improvements based on this? Tracking sales trends over time helps identify seasonal opportunities or warnings. We multiply quantity by price to find the value of each transaction. We then resample sales data by month and sum the totals. The output shows sales for the most recent 6 months. Running the cell now. This output shows the total monthly sales revenue over the last 6 months of the dataset, calculated by multiplying quantity and price for each transaction. Notice the notable sales increase from September to November, likely reflecting seasonal demand, followed by a sharp decline in December. This highlights how resampling time series data helps uncover important trends in customer purchasing behavior over time. What time of year seems strongest for online sales in this data? Advanced analysis. Let us find which new customers are most likely to leave. Customers who both churned and had short tenure are considered at risk. We calculate the percent of all customers that fit this pattern. The output helps businesses develop targeted retention campaigns. Running the cell now. This output reveals that about 14.7% of new customers with a tenure of 1 year or less have already churned, highlighting a key risk group. The code filters for recent customers who left, helping us focus retention efforts where they matter most. Noticing this proportion allows us to target early satisfaction improvements to reduce churn in this vulnerable segment. How could you reduce risk among new customers? Customer lifetime value measures the total revenue a customer brings over time. We group retail sales by customer and sum their transaction values. Sorting these values reveals our most valuable customers. This helps businesses focus on rewarding their best clients. Running the cell now. This output shows the top 5 customers ranked by their total purchase value, highlighting their customer lifetime value, CLV. Notice how the code sums all sales per customer to identify these high-value clients, which is crucial in understanding which customers contribute most to revenue. This step reinforces the importance of grouping and aggregation when analyzing real-world retail datasets to drive targeted marketing strategies. Suggest one benefit to businesses of knowing their top customer lifetime values. Businesses want to track customer sentiment over time across regions. We assign each NPS response to a random month for demonstration. We group by both region and month to see trends. The output shows how NPS scores have changed recently in each region. Running the cell now. This output shows the average NPS scores over the last 6 months for each region, highlighting trends and variations in customer satisfaction by area. Notice how grouping by a region and month then unstacking creates a clear, comparative table of scores over time, essential for spotting regional patterns or anomalies. This step underscores the importance of temporal and categorical grouping in analyzing survey data to inform targeted marketing strategies. Imagine you are the regional manager. How would you respond to a downward NPS trend? Missing data is common in surveys and can bias results. We count how many missing values appear in each column. The output highlights which survey fields might need cleaning before analysis. Running the cell now. This output shows that there are no missing values in the customer satisfaction survey dataset, as indicated by the empty series. This confirms the data is complete for all columns, which is important before performing any analysis to avoid biased or misleading results. The code demonstrates a crucial first step in data cleaning, checking for missing responses to ensure data quality. Practice: how can missing values impact business decisions? If you want more tutorials, check out YouTube for practical analysis walkthroughs. Incorrect aggregations are a common mistake. Here we try to calculate the mean of a text column. Grouping by NPS score and averaging text regions does not work. We use a try except block to show the resulting error without stopping the lesson. Running the cell now. The error message here highlights a common mistake when working with survey data, trying to calculate a mean on categorical text columns like region. Since a region stores non-numeric data, aggregation functions like mean can't be applied. This reinforces the lesson's point about carefully checking data types and avoiding invalid operations when summarizing customer or market datasets. Always confirm column types before aggregating. Can you fix the code? New analysts sometimes mislabel the NPS cutoff for promoters. Scores of 9 or 10 are true promoters. Hence, we use greater than or equal to 9 rather than just above 8. Running the cell now. This output shows the percentage of customers classified as promoters based on NPS scores of 9 or above. Notice the 17% indicates a relatively small fraction of highly satisfied customers in the survey, highlighting the importance of correctly filtering the scores to avoid misinterpretation. This reinforces the lesson on carefully handling rating scales and ensuring accurate group definitions in real-world datasets. Why is it important to use the industry-standard NPS categories? Best practices for market research analytics. Segment results by customer type, location, and tenure to find patterns. Use crosstabulation to see how two variables interact, e.g., churn by contract type. Construct indexes or summary scores for easier business decisions. Visualize time trends to catch seasonal effects or sudden changes. Running the cell now. Crosstabs quickly reveal how churn differs by contract type. We use crosstab to compare churn rates across contract options. Normalization shows the percentage of churn within each contract group. Running the cell now. This crosstabulation shows the proportion of customers who churned versus stayed, segmented by contract type. Notice the clear trend: month-to-month contracts have the highest churn rate, about 43%, while 2-year contracts have the lowest, around 3%. This helps identify which customer segments are most at risk and guides targeted retention strategies. Which contract type should management promote to reduce churn? Tracking customer acquisition across months helps spot business growth. We bucket transactions by the month of invoice. We count unique customers per month, revealing trends over time. The output displays the latest monthly new customer counts. Running the cell now. This output shows the count of unique new customers acquired each month over the last 6 months of 2011, highlighting a rising trend from July to November before a sharp drop in December. Noticing these fluctuations helps identify seasonal patterns or events impacting customer sign-up volume, which is crucial for timing marketing efforts and resource allocation. This aligns with best practices for trend analysis to detect business cycles and inform strategic decisions. Practice: what could cause a sudden dip in new customers? Tiny end-to-end problem, from survey to strategic recommendation. Suppose NPS dropped in the West region for 2 consecutive months. What action should management take? Analyze the NPS trend, identify the segment, and prepare a short recommendation. Running the cell now. Let's focus on the West region NPS trend. We select only the West region scores from our earlier trend analysis. We display the last 3 months to spot changes. This highlights whether there is a real and urgent decline. Running the cell now. This output shows the recent NPS scores for the West region over the last 3 months, revealing a small drop in November followed by a slight uptick in December. Noticing this trend helps focus the analysis on the cause of the dip in November and informs whether the decline is persistent or improving. This supports the lesson's goal of identifying and understanding regional NPS changes to guide management actions. If a real drop is seen, recommend specific service or product improvements. Remember to subscribe to our YouTube channel for more real-world analytics tips.